Hello, welcome to Chris Khan Academy, the YouTube channel which brings you about mathematics and biology. So now we are going to discuss about mathematics, where we discussed at the last session on the general introduction and the generalization of statistics and probability. There now we are going to see different formulas in generalization that are applied in statistics and probability in general. So I would like to invite you to make subscribe, comment, share and like about this video such that you can be ready to do this. So welcome. So starting from, let us see descriptive statistics. Descriptive statistics. So in descriptive statistics, it is where we find different grouped data and ungrouped data. You have grouped data and ungrouped data. So in grouped data and grouped data, there are different formulas that are used in calculation of, for instance, mean, variance, standard deviation, and so on. So let us see those formulas that are used in that grouped data. So here starting from ungrouped data, in ungrouped data we have mean. First one, we have mean. The formula of calculating mean for ungrouped data, it is equal to mean is symbolized like this one, which is equal to summation of fx divided by sum of frequency. This is the formula used to calculate the mean on the ungrouped data. The sum of fx, you have to multiply x with the numbers that f with the numbers that are given, and then we have to find the total of the frequency and the total of that fx, and then we got the value of mean. So there is also what we call variance. Second one is variance for ungrouped data. How to calculate the variance, and it is symbolized like this. In general, it is equal to summation of x minus mean, then is squared, divided by n, which stands for total frequency. This is the formula of calculating variance in the ungrouped data. So let us see this is let us see another point. It is what we call standard deviation. Standard deviation. On the standard deviation, where it is symbolized by this letter, it is equal to, the standard deviation is equal to summation of x minus mean, x mean in a square, then divided by n, in general in square root. This is the formula of calculating standard deviation of ungrouped data. So I think you have heard each and everything about ungrouped data. Let us shift on on formulas of calculating mean, variance, and standard deviation for grouped data. For grouped data, the formula of calculating variance. Let us start on variance. On variance, which is symbolized by this symbol, and the formula is equal to x minus x mean squared divided by sum of f. And this simply means to be the same as writing sum of fx divided by sum of f, then in general square root. This is the formula of calculating variance in the group T in the group T data. Let us see how to calculate standard deviation in the group T data. Standard deviation in a group T data, it is symbolized also like this one. As you see it, then it is equal to summation of fx minus x mean, then squared divided by sum of f. So in general, then we put it in square root. This is the formula of standard deviation for the part of group T data. So here there is another formula that is used in statistics, which is finding midpoint of given part. For instance, in grouped data, the midpoint on grouped data, we find it by using upper class limit plus lower class limit, then divide by 2. This is how you find the midpoint on the group T and the group T data. So in the statistics, there's what we call Poisson's skewness. It is where you have Poisson's coefficients, and we are likely to find that Poisson's coefficients is equal to mean, then minus mode for the grouped data, then divided by standard deviation. So this is the formula of calculating Poisson's coefficients. So another formula in statistics and probability, I can tell you, it is what we call fx. In general, fx, it is equal to, on the grouped data, it is equal to midpoint times the frequency. This is the formula of calculating fx on the grouped data. You have asked that formula. So this is the part of statistics for grouped data. And also there is another thing that we looked out in statistics, where you're given a data and then we ask you to calculate what you call quartile and percentile. So there are different formulas that are used to calculate quartile and the percentile. So starting from the quartile, have the quartile on grouped data. These are likely to be applied in a grouped data. You have to first find the position of that quartile, and there is a formula that is used to calculate or to find that position of quartile. The formula used to calculate position of quartile, it is k over 4 times f, and this f stands for frequency. So this is what we call position of quartile. So there is also how we can calculate the for decile. Position of decile, we calculate position of decile by finding k, where k is the number, then over 10 times the frequency of that number. Then this is what we call decile position of what, of calculating decile. So here there is also what we call percentile. The formula of calculating position of percentile, it is kn divided by 100. Then this is as a position. You have to add 8. If we go to 4, it is fourth. If 5, this is the position of percentile. This is the formula used to calculate what? Position of percentile. So here there are different also formulas. Already the formulas used to calculate those things. Here in quartile, so for the quartile, the formula of calculating quartile, you have to is qk, which is equal to LK. LK is lower class limit, then plus Kn divided by 4 minus Fk, where we find that Fk is the cumulative frequency before the class boundary, then divide by F small k, where F small k stands for the frequency of the class limit, then in bracket times ck, where ck stands for the class boundary of that or class limit. So this is the formula of calculating quartile. And let us see the formula of calculating percentile. For the percentile, we calculate percentile by using this formula. Pk stands for percentile of k. K is constant from counting from 1 to n, then which is equal to Lk Lk plus, it is our class limit for the what, for the class selected, or the position where the position of the percentile found, plus bracket Kn, where this varies from 1 up to n, then minus Fk, cumulative frequency of the class limit. Here this Kn is divided by 100 as is percentile, then divided by, in general, Fk. This is the cumulative frequency of the cumulative frequency before the class boundary. It is the Fk, where it is this F, it is cumulative frequency of before the class limit. What is frequency for the class limit? This is f small. Then in general times ck. This is the class limit of the class boundary. So this is the formula of calculating what we call percentile. There is another formula which is necessary. It is how to calculate mode and median for the group T data. Mode and the median for group T data. So there are different formulas that are used in calculating mode and median for group T data. Let us see these formulas. Starting from mode, the formula of calculating mode, it is L1, which is lower class limit, plus f big capital letter minus f0, then divide by 2 f1 small minus f0 minus f2, then bracket in general L2 minus L1. This is the formula of calculating mode for the group T data, where F1 stands for the frequency of the model class, and F0 stands for frequency of class for the mode, and F2 frequency for the class after the mode. And here, this is the formula of calculating that mode. Let us see on the side of median. The formula of calculating median for the group T data, we have to L1, which is plus n over 2, then minus cumulative frequency before class limit, and divided by the frequency of that class limit. So then times then L2 minus L1. So this is the formula of calculating median for the group T data. I think you are heard, or you are getting each and everything about this one. So there is what we call relative frequency and the percentage distribution. If we say the relative frequency, there is a formula of calculating relative frequency, which is equal to frequency of class over total frequency. Frequency of class over total frequency. This is the formula of calculating relative frequency. So there is what we call percentage distribution. For the percentage distribution, it is equal to frequency over sum of frequency, then times 100. This is how we calculate the percentage distribution of the given data. And then I think we are in the point of finding the different formulas that are used in statistics. And this is the part 1 for the statistics, and at the next session we will see on the part of probability the formulas that are used in calculating different events that are used in probability. So thank you very much. Let's continue to the next video that shows the formulas that are used in probability, and I would like to invite each and everybody to make subscribe, share, comment and like, such that you can get each and everything about this channel.